Hi, this video is going to go through question 17 from the 2018 OCR Synthesis and Analytical Techniques paper. I will attach below in the introduction the information below the actual question. Otherwise you can search for it and find it online. Give the question a go first before watching this video. So, question starts with the alpha amino acid cysteine, where the R group is CH2SH, shows optical isomerism. You have to draw a 3D diagram to show the optical isomers of cysteine. So we start just up here with what a amino acid is, the general formula. We have an R group there and H. And so it's already told us in this one, the R group is CH2SH. So that's its displayed formula. What we need to see is its 3D formula. So I'm going to put CH2SH going straight up. Coming down this way, I'm going to put the amine group. Coming out towards me with a wedge, and put the H. Then going back, I'm going to put the COOH, the carboxylic acid group. So that's one of the 3D structures. Now it does ask to show the optical isomers, so I have to draw the optical isomer. So this is my mirror plane. Carbon in the middle. I can put my CH2SH still going straight up. Now, going over here in the same plane, got my amine group. Coming out towards me down here, got my hydrogen. And then over here, I'm going to have my carboxylic acid group. And that's then my isomer. And they are mirror images of each other. In part B, it says the amino acid lysine reacts with an excess of dilute hydrochloric acid to form a salt. Draw the structure of the salt formed in this reaction. So its R group is a alkyl chain followed by an amine group at the end. So this is important. It's got two amine groups. So when it forms a salt, we normally have a hydrogen being taken on by this nitrogen, and that gets then a positive charge. Now though, because it's got an amine group elsewhere that also takes on a hydrogen, gets a positive charge. In hydrochloric acid, the carboxylic acid is going to stay as it is. It's not going to dissociate. I've just got a hydrogen coming off here. So then, along with the amine group, if it's hydrochloric acid, I'm going to get a Cl- and a Cl- there. So that's going to be the salt formed. So key thing to spot in this, that there'll be there's two amine groups, so we get two ammonium salts. In part 3, alpha amino acids can react to form proteins. A short section of protein chain is shown below. A student hydrolyzed the protein with hot NaOH. So the key thing here is that we've got base hydrolysis. So it's hot NaOH. NaOH aqueous. Draw the structure of the organic products formed from this section of the protein. So what we're going to get formed from here is the carboxylate ion and the alcohol group wherever we've got an ester bond. So the ester bond will break and we'll get the carboxylate, which will then form into a salt with a positive sodium, and the alcohol group will stay as it is. If it's an amine, we'll get our carboxylate and we'll get our amine group back again. So alcohol and amine, they go back as normal, but when it's the carboxylic acid, it becomes the carboxylate. So we'll have OH, CH2, CH down here. We've got that amine group, which is the start have an amide bond also on the other side. So that's going to go to NH2. As we said before, it goes back to NH2 and it's amide bond. Then we're going to go down here. We're going to get CO, O minus, and that'll form a salt with Na plus. So that's the first separation. The second one will have CH with coming straight up our carboxylate, which again form a salt with sodium. And coming this way, we'll have an amine group reform. Coming down, CH2 into CO O minus, and get an A plus, and we'll get our ammonia reforming down there. So is it 3 marks? Go with 1 mark for this structure with the salt, 1 mark for this structure, the salt there, and probably 1 mark for the ammonia. And that's all of the question.